So what we're going to do is look at part 3 of going through the summer packet for Algebra 1. We're going to be looking at scientific notation and we're going to be looking at radicals. Now, when we're talking about scientific notation, what we're doing is we're talking about a number in between 1 and 10. And then our exponent above 10 is going to be an integer, and that would be a positive or negative whole number. So as an example right here, we have 710,000. And what we're going to do is turn it into scientific notation. So this number has to be a number in between 1 and 10. Now, if we don't see a decimal, we know that the decimal's at the end. And a number in between 1 and 10 would be 7.1. So that's why we have 7.1 right here, because 7.1 is a number in between 1 and 10. Now, in order to figure out the exponent, what we do is we look at our decimal and we count how many spots in order to get it to in between 7 and 1. So 1, 2, 3, 4, 5. That's where it's 5. It's a positive 5 because this is a large number. So if it was a small number, we have a negative exponent. Large number means positive exponent. Now, for a more difficult problem, like letter B, we have 4 times 6, which is 24. And then what we do is we add the exponents, like what we did with the exponent review. So 2 plus 5 gives us a 7. Now, 24 is not a number in between 1 and 10. So what we're going to do is we're going to make it a number in between 1 and 10. So that would be 2.4. Since we move the decimal over 1 and 24 is a large number, we're going to add 1 to the 7. 7 plus 1 gives us an 8. So let's do a few examples. What we have right here is 67,800. So a number in between 1 and 10 would be 6.78. And remember, if we don't see a decimal, it's at the very end. 1, 2, 3, 4. Since it's a large number, it would be 10 to the 4th. Now, looking at letter B, what we need is a number in between 1 and 10. That would be 5.12. 5.12 is in between 1 and 10. When we move the decimal to that spot, 1, 2, 3, 4, it would be times 10 to the 4th. But remember, this is a small number, so that would be negative 4. Looking at the next one, 9.99 would be a number in between 1 and 10. 1, 2, 3, 4, 5, 6. So that would be times 10 to the 6th. Let's look at the one right below it. 20 times 8 would be 160. And remember, when we multiply, we add the exponent. So that would be times 10 to the 7th. We need a number in between 1 and 10. So I'm going to go 1, 2. That would be 1.6. You could put a 0 if you want, times 10, and then we're adding 2. So 2 plus 7 gives us 9. Now what we're going to do is we're going to switch. What we have is a number in scientific notation. We're turning it into standard notation, which is just a normal number. We see it's in scientific notation. Negative exponent means we want a small number, so we're moving to the left, 1, 2, 3. So it would be 0.00722. Looking at the next one, this is a large number. We have our decimal right here. We're moving it 5 spots, 1, 2, 3, 4, 5, meaning it's going to be 816, and we're going to have 3 zeros. Let's look at the next one, 19. If we don't see an exponent, we know that it's 1. So that means that we're moving the decimal over 1. Decimal's always at the end of the number if we don't see it. If we move it over 1, that would be 190. And a negative 1 means we move it to the left 1. So it would be 0.31. Let's look at letter H. We're going to multiply the 8 times the 9, which is 72. We're going to add the exponents. 3 plus negative 5 gives us negative 2. Negative means it's a small number. So we move it 2 to the left, 1, 2, making it a smaller number. So that would be 0.72.